Hello students, let's go through the question. A particle moves along a straight line. Particle move along a straight line. Let's highlight the important keywords. So the important keywords for this question are example, straight line, passes through a fixed point O. Fixed point O is very important. Velocity 20 meters per second. This is very important. The acceleration of the particle a meter per second is given by a is equal to 11 minus 60, where t is the time in seconds after passing through O. So we are going to find the maximum velocity of the particle, the distance of the particle in the third second, and the time when the distance of the particle from O is maximum. And then we will sketch the velocity graph of the motion of the particle from time 0 to 5 seconds. Now let's get started with solving the question A. For question A, we need to find the maximum velocity. In order to find the maximum velocity, we must let a equal to 0, because when acceleration equal to 0, the velocity is maximum. So the a in terms of t, a is a function in terms of t, 11 minus 60. So we let a equal to 0. The time is 11 over 6. Alright, so that is the time whereby the particle is having maximum velocity. So in order to find the velocity, we need to integrate the acceleration. So let's integrate acceleration 11t minus 60 squared over 2 plus c. Don't forget to plus c. So when t0, velocity is 20. So hence the c is equal to 20. So this one is when you read the question, when the particle at the fixed point O is velocity is 20, right? So finally, we need to write again the velocity in terms of the t, which is 11t minus 3t squared plus 20. So this is the velocity function in terms of the t. So we're going to substitute the time 11 over 6 into the velocity function, and we'll solve it to find the velocity, which is so-called maximum velocity. So the answer is 361 over 12 if you press the calculator. Now for the next one, we are going to find the distance in meter traveled by the particle in the third second. So let's see how to solve distance. So in order to find the distance, we need to actually use the velocity. We need to integrate the velocity. So let's integrate it now. So integrate 11t minus 3t squared plus 20 dt. So we'll get 11t squared over 2 minus 3t cubed over 3 plus 20t plus c. Don't forget the c is very important. So how to solve the c is the particle passes the fixed point, right? When t0, s is 0, so c will be 0. So we can just ignore the c. So in order to find the distance in the third second, we need to find the displacement for the particle in the third second minus the displacement of the particle in the second second. So let's substitute 3 into the displacement function. So we have 11 over 2, 3 square minus 3 cubed plus 20 times 3 minus 11 over 2, 2 power 2, and 2 power 2, and then 2 cubed plus 20 times 2. So if you press a calculator for the displacement in the first 3 seconds is 82 1/3, and the displacement in the first second is 54. Hence, the displacement in the third second is 28.5. Alright, so for the next one, for part D, let's focus to part D when t0. We have the information, velocity 0. Alright, so the time is 5. Alright, when a is 0, velocity is 31 over 12. All this information will help us to plot the graph. And the velocity maximum happened at time 11 over 6 seconds. Right? So we need to jot down the maximum point, which happened at 11 over 6 and 31 over 12. Alright, so let's get started with sketching of the displacement time graph. Right, so in order to sketch, we need to draw the axis. Vertical axis will label with V, horizontal axis will be T, and this is N-shaped graph, right? So make sure you label the important point such as y-intercept, and the most important is the maximum point. It happened at 11 over 6 and 31 over 12, and then the x-intercept. So every time when you sketch a graph, make sure you label the maximum point, the v, okay, the v-intercept, and the time intercept. We don't have x and y. Don't forget. That's all my sharing for today. Till then, bye-bye and have a nice day.